All right, welcome to United Astronomy Clubs of New Jersey. We're here on site in Jenny Jump State Park in Hope, New Jersey. Fortunately, it's very rainy outside, so we are currently inside in our little smaller lecture area. Um, that being said, great shout out to our people down at Jenny Jump State Forest. If you ever want a good place to hike, camp, all that, do check them out. They always have cabins available, and a lot of people who come up here have ended up camping down there and wander up from their campsite. You can also check us out at uacnj.org. It's where you're going to find a list of all our upcoming programs, as well as a list of our member clubs and all sorts of fun things to do with the astronomy and science we do here. We do live stream these presentations on YouTube and Twitch, so for those joining us online, do feel free to hit those like and subscribe buttons on YouTube or the follow button on Twitch. They're all those actions are completely free to do, and helps us out get the science and astronomy out to more people. In addition, you can check us out on our social media pages, our Facebook, our Instagram. We have a Discord server. All great options if you have questions about your telescope rig, what's up in the sky. We'll always try and get an answer to you. And for some of the more complicated questions like I think someone had asked some weird math question. I'm like, I'm not smart enough to answer that. Math was never my strong suit. But besides the point, we will do our best to get you an appropriate answer. So tonight's program, or actually before we get into tonight's program, people here, unfortunately, you cannot escape the safety briefing. If you need to use the restroom, it is the porta potty outside. It is illuminated by red to make it easy to find when it gets darker. Unfortunately, I highly doubt we're going to have stargazing tonight, as the only gazing we can do is at clouds and rain. So when we do go to leave here, we are using our headlights. Even if it was clear, we still always use our headlights because we do not like getting run over, nor do filling out the paperwork when people do get run over. People very rarely get run over. Don't make me worry you too much, but it is something to keep in mind. Since we are indoors, you did actually come through our little museum and gift shop area. Feel free to check that out after stream. I will be manning the little counter over there. Unfortunately, can't do two things at once. Only one person. Haven't given me the technology to split myself in two.
Not yet.
I've had many a manager go, man, if only I could just like clone you and duplicate you. No one's ever bothered to take that technology out for me, so unfortunately you have to deal with only one of me. Or fortunately, depending on your view. With that, tonight's talk is What's Up in the August Sky. This talk is given on the first Saturday of every month with Lonny Buinis. Lonny has been giving this talk series since UACNJ opened in 1994. He received degrees from Stevens Institute of Technology in Physics and Computer Science, then learned space art, animation, and video on his own. Lonny is the only member of the IAAA.org who specializes in virtual reality worlds, and he wrote his first interactive space history ebook and is most pleased to have married Jan, his narrator. Honestly, one of the best decisions you've made. With that, here's Lonny.
Thank you very much, Kim. It's great to be here. Oh, wow, applause. Wow. I don't know if I deserve that. Thanks. This series wouldn't be possible without the dedicated work behind the scenes of all the UACNJ people, including Kim, who you just saw, and Chris, and many others. So I'm grateful to them for the technical help. I'm going to stand out of the way. I hope I'm still in camera range so you can see the screen. And we're looking at what is up in the August sky. If you look pretty high up in the sky for the summer triangle. Astronomers have brilliant names for things. 3 bright stars that form a triangle in the summer sky. Wow, summer triangle, the technical name. But if you look in the middle of that triangle, you'll find a constellation called Vulpecula, the fox. It's made from these two stars. Brilliant. I don't know how our ancestors looked up there and said, oh, a fox, obviously. But we're going to see a lot of things like this a little bit later when I simulate the sky with a free computer program that you can also download or run without downloading or on your mobile devices. Right there is one of my favorites, and right here, a thing that's not a constellation, and we'll explain that later. This one, by the way, is the Arrowhead Sagitta. 1, 2, 3, 4, 5, 5 stars. It beats the fox. So let's find out what's up or what's going on. First, a little bit of history. In this month, in 1959, I was still alive back then. Wow. Explorer 6 brought back the first, or sent back the first images of the Earth by a satellite. Fantastic quality. Look, I can see my house right there, New Jersey. I have no idea what I'm looking at, but it was the first TV transmission as well in August of 1959. And then going a little bit further back, in 1560, my hero, Tycho Brahe, was an astronomer, didn't have telescopes, binoculars, no optical aid back then. He had a giant astrolabe, giant protractor that he used to measure the positions of stars and planets with just his naked eye. And his measurements were so precise that his student, Johannes Kepler, used that to figure out how planets move, figured out the rule that guides the motion of planets, especially the planet Mars. Except that Tycho Brahe was very intimidating. He worked hard, he partied hard. So when Kepler heard all about this master, couldn't wait to meet him, was horrified when he first met him because the slob walks out heavily partying, full of food on his clothes, on his beard. He was absolutely horrified, but he was grateful for the measurements. My hero, Tycho Brahe, was inspired after seeing a solar eclipse. Anybody here see a solar eclipse recently in April? Everybody? Yep. Yeah, I actually traveled to go see it into New York. So he was inspired when he was young, Tycho Brahe. So here's what's up. We're going to memorize this. There'll be a test later. I marked all the morning events for those of you who don't like to get up at 5 in the morning. There are some nice groupings of the moon moving past planets, which will become easier to see in the nighttime later on this year. So if you come back for what's up in September, October, then we'll be seeing some of these things like the planets Jupiter and Mars in the evening sky. But right now they're in the morning. So I'm going to jump around. I'm going to pass over what's happening early and go to the 14th to see Jupiter near Mars in a group of stars that's open. So astronomers, being brilliant, call this an open cluster of stars. They were born together. They moved through space together. They moved apart a little bit. And they form the face of something that's in the zodiac with long horns. Very intimidating animal. Any guesses? Correct, Taurus the bull. And right there, Mars and Jupiter will be very close on the night of the 14th. If it's clear, go out, well, at 5 in the morning if you have to get up early for work. One of our astronomers here, Matt Heiss, works as a park ranger, so he's up at 5 every morning. He'll see it. It's a beautiful grouping. And the moon is going to move right through this area to make another grouping as well a little bit later. Here's what it looks like between the 10th and the 18th, and the closest that Mars passes Jupiter is on the 14th. Mars moving through the sky more quickly than Jupiter. Why would that be? Well, Mars is closer to what than Jupiter? Further than Earth from the sun, right? So Earth is 1 astronomical unit. So astronomers don't use miles, 93 million miles. What's a million miles? No idea. We don't have a good feel for that. Actually, the James Webb Space Telescope is about 1 million miles out toward the sun at Lagrangian point 2, stable gravitational point. That's a lot of miles, but 93 million is ridiculous. So sun to Earth is 1. Sun to Mars, 1.5. Sun to Jupiter, 5. Mars is moving more quickly through the sky. And here's what it would look like if you could see Jupiter as a small disk in a small telescope. That's how far away Mars would be. So several telescope fields of view, very narrow, more like 1, 2, 3, 4, 5, 6, 7, 8 or so. On the 20th, the moon is near Saturn, but this is at 10 o'clock, 10:10. I picked 10:10 because Mars and Moon and Saturn are at its closest, their closest distance apart. In the southern part of the world, Saturn will actually go behind the Moon. It's actually the Moon will pass in front of Saturn. So that's called an occultation. Occultation. We in New Jersey won't see that. We'll see a very close grouping, the Moon very close to Saturn. And that's in the constellation Aquarius in the zodiac. That's the water carrier. And that's not in the morning. I marked it as morning because Saturn used to be easier to see in the morning. My mistake. August 20th, the moon is near Saturn. And if you could look at the moon large enough in a telescope so it looked like this, that would be a small telescope. You don't need a big one. You would just see the disk of Saturn. With the rings very thin, they're going to disappear shortly. Why would the rings of Saturn disappear? They're bigger than Saturn, right? Saturn is 9 Earths across. Earth would be a little tiny dot. The rings are 170,000 miles wide. Earth is 8,000. The rings are only 10 meters thick, 30 feet. So if you made a scale model, as I did, I made a scale model of Saturn. The rings were this big. I airbrushed dust, paint on plexiglass. The microscopic paint particles were too big. Can't make a scale model good enough. August 27th, moon passes Jupiter in, again, Taurus, the bull, right near Auriga, the chariot rider. And then the moon will, the next night, pass by Mars. 27th, 28th. What's happening here? We're looking at the same part of the sky at 5:30 in the morning. Still 5:30 in the morning the next night. What's happening? Well, the constellation shifted a little bit. Why would that be? We're looking into the same part of space, night to night. What happened? The Earth is also moving around the sun. So as it does that, we get a slightly different view if we nail down exactly the time and position. The moon moves very rapidly through the sky because it's going around the Earth once every 27 1/3 days. So that's the 27th, 28th. If you get up early, you can see all this neat stuff. If you don't, like me, get up that early, then something to look for is Venus and Mercury. The inner planets are close to each other on August 7th. That's just a few days from now. From here, from the United Astronomy Clubs of New Jersey, that's a mouthful, I just abbreviate it by the website UACNIJ. Repeat after me, UACNIJ. UACNIJ.org, that's our site. Go to UACNIJ, you'll see 7 observatories. This one is the Lonny Buinis Observatory. They honored me some time ago. Don't know if I deserve it. But you will see Mercury and Venus right near the crescent moon with the new moon in the old moon's arms. Very poetic description. Go out, look for the crescent moon and see why they call it the new moon in the old moon's arms. There's light on the dark side of the moon coming from the Earth. Very good, Earthshine. And it's kind of bluish. So if you were standing on the moon, on somewhere on the dark side, escape. Wrong move. If you stood somewhere on the dark side of the moon looking at the Earth would look blue. The landscape would have a bluish light from Earth light. Cool. August 7th, Mercury and Venus. How about the phases of the moon? Every month we have at least 2, sometimes 2 full moons in a month. That's called a blue moon, once in a blue moon. Happens every so often. August 4th, August 19th. So early in the month is a spectacularly good time to see faint objects, a nice clear sky. when the moon is not in the night sky. And an absolutely horrible time is the supermoon. We're going to see why it's called the supermoon. I like to go to moongiant.com, for which I do not work. Right? I have no affiliation with any of these sites except my own. You can get the current phase of the moon, a thin waning crescent. Waning moons are in the morning sky. Waxing moons are in the evening. So you'd have to get up pretty early to see this moon getting closer and closer to the sun. You can you can click on links to see other times. You can get a beautiful calendar like this for each month. And I've highlighted with this button down here the major phases. So great time to see faint things like the Milky Way. Full moon later in the month, horrible time to see anything except clouds, maybe. Well, in New Jersey. Where I live in Bergen County, I see very hazy skies. So I'm waiting for the planets to come back into the night sky so I can use my telescope that I haven't looked at in 10 years. My wife bought me a great little telescope 10 years ago. Just started using it this year. And she's watching this presentation, so she's probably wincing right now. The quarter phases of the moon, great time to see detail on the terminator, boundary between light and dark. And when I first saw the moon in a telescope when I was young, I saw little white dots right along the terminator, and I thought, wow, that looks like cities. But we know there's no cities on the moon, so what could those have been? Audience participation is not punished. Those are mountain peaks, right? You got it. But this, I'm just gonna ask this one right here, all the questions. Those of you in back, don't feel shy. You can shout out wrong answers. I won't ridicule you. Thank you very much. Yeah, mountain peaks catch sunlight first, just like on Earth. So you'll see, use even a small telescope, you can see mountain peaks on the moon. So first quarter, if you're up at night, right after as the sun sets, the first quarter moon is due south, which at Jenny Jump is that way. North, south, sun sets in the, don't make me ask her, west, thank you. And then in the morning sky last quarter, if why are we calling this a quarter? Right, the moon is a sphere. Half of it's always lit up, right? But we can't see the other side of the moon because the moon has captured rotation. Every major moon in the solar system, did you know this? All the big moons of the solar system have captured rotation. They go around their parent body, like the moon goes around the Earth 27 1/3 days. The moon rotates 27 1/3 days, so we see one side all times. It's called synchronous rotation. Every full moon has a name, has many names. I just picked one, the sturgeon moon for this month. The sturgeon are ready for capturing, for fishing. I saw a guy fishing by the waterfall in Saddle River recently. Don't think he caught any sturgeon, though. They're not native to Saddle River. But they have some beautiful poetic names, Native American names. Also, there are a lot of names from the Farmer's Almanac. So you'll find all kinds of names for each full moon. One website is starwalk.space. Why is this a supermoon? Every once in a while, the moon in its elliptical orbit around the Earth, it's not a circle. Sometimes it's closer, sometimes it's further. We have names for that. Periapsis, close, or perigee, apogee for a moon. Apsis would be for other objects, perigee, apogee. So it just so happens that once in a while the full moon happens when it's closest to Earth. It's a little bit brighter, 15% maybe. It's a little bit bigger, a few percent. Would you notice the difference when you read the newspapers? Excuse me, nobody reads newspapers anymore. When you see the news, you'll see the biggest moon ever. You gotta look at the moon. It's as big as it's ever been in months. You won't notice a difference, but you might notice it's a little brighter. That's a supermoon. Big deal. All right, so the big thing, if you forget everything else I've said tonight, my wife's not going to forget that I talked about her wincing. But you don't forget the meteor shower. And if you miss the peak, if it's cloudy, like it is a lot where I live, or if there's a lot of haze, August 12th is just the peak. This thing has a range. It's the Perseids named after Perseus, the hero of legend. And that is something worth seeing. We have a simulation of the orbit of the comet that made the debris that we go into every year. Every mid-August, we pass through this tunnel of debris, and the little pieces hit the atmosphere and burn up. And they're, how big are they? Are they like that? Watermelon? Cantaloupe? Grapefruit? Apple? Grapes? Sand grains. Sand grains coming in at Mach 171 times the speed of sound. The fastest things that anybody's ever made. They're trying to make hypersonic missiles that go Mach 20. Very difficult. The atmosphere is like a liquid at that speed. Creates a lot of instabilities. This thing is coming in at 60 kilometers a second. Very fast. They disappear in seconds. They burn up. But if they're big enough, they make it to the ground. Then they're no longer a meteor. They're a meteorite. And you can see some of those that came from Mars or the moon out there in our display area with our gift shop. Shameless advertisement. We have stuff for sale. Hourly rate 100, which means where we live, you might see a few bright ones every hour. So try it out. You have a chance, though, from July through September, right? It's a bell curve. So the best is around the peak, around the 12th. If it clouds out, don't despair. Just try it a little before or after. And this comet goes around every 133 years. There's a really neat animation on Wikipedia. All the meteors are going to stream out from a single point, even though they're in parallel tracks. Right? We go through the orbit of the comet. It's parallel. But do railroad tracks actually ever meet? They look like it. It's an illusion, right? Parallel. So the meteors similarly come from a illusional radiant point. In Perseus, the hero looks just like a guy holding Medusa's head with the eye. That's a cool star, though, Algol. It's a winking star. Two stars revolve around each other. They eclipse each other every few days. You can see that just with the naked eye. You can actually watch the eclipses. Cool. It's near Cassiopeia, the W, or Queen. So what do you need? What do you need to see a meteor shower? This is very important. There's some complex equipment. You need some of this. You need something like that. Bigger is better, right? And that. So are you prepared? No, you don't need any of this. What you need is your naked eye. This is a sculptor who does some pretty cool work. You don't even need this, just your eyes. You need a comfortable chair. You need bug spray in case you run into any of these. And you need your naked eye. And the best thing to do is don't do what he's doing. Lie all the way back. Look at the entire sky. Try to get a wide angle because the meteors will streak in every direction from the radiant over your shoulder coming from Perseus, which rises late. The later you can stay up, the better. We look at right into the Earth's shadow around midnight or so, depending on daylight savings time. But if you can't stay up late, don't worry. Just try it before. Other thing to look for, this is the last thing before we actually look for things in the sky. T Corona Borealis is a faint star in the crown corona in the north Borealis. There's a Corona Australis also in the south. But T, wow, what a brilliant name, T Corona Borealis. The Blaze star, I like that name, is a double star. It normally looks red because we're seeing light coming from a red giant star much bigger than the sun, but it's orbited by a tiny white dwarf star the size of a planet. And it's sucking down material from the red giant, and every once in a great while, the material builds up so the impact point fuses. Nuclear fusion, gigantic explosion, and it becomes a nova, the word for new, nova. And this thing will brighten from just about invisible magnitude plus 10 is 5 magnitudes fainter than what the naked eye can barely see here in New Jersey skies, magnitude 5. The higher the number, the fainter the object. Magnitude 0 is a planet like Saturn. -4 is Venus. -11 is the moon. Bright stars, 1. Magnitude 10 is 100 times fainter than magnitude 5. So every 5 steps, 100 times. This thing is going to brighten to magnitude 2, but we're just not sure when. That'll be as bright as the stars of the W in the north, and I'll show you where to look. This happened in 1946, back in 1866, way back in 1217. The last time it happened, it dimmed just like it did in 1946 in 2018, and it brightened. It had this pattern of brightening and dimming. It did the same thing in 2018 and the same thing last year, a temporary brightening, signaling that something's going to happen between April and September this year. Has it happened yet? No, we're a little bit late. So we may be able to see the blazed star here in the crown below Epsilon Corona Borealis. Let's take a closer look. It's also near Hercules, the hero, and to see that in the summer, you just look straight up. Face south. At Jenny Jump, it's that way. Look straight up for the letter H for Hercules. Look to his right, crown. And it looks something like this. This is a simulation from Stellarium, free program that you can use. That's the blazed star, very faint, barely visible in Stellarium. And it's going to make a nice triangle that's almost not quite a right triangle, isn't it? Right triangle would be 90. This is more than 90 degrees. So that's one way to find it, between epsilon and I think that's delta. Is that? No, that's not delta. That's, anybody know Greek letters? Is that it's not zeta or lambda? Chi? Geez. There's delta, epsilon, blah, blah. I don't know. Look it up. So that's what we're going to look for. And I haven't had a chance to look for it yet. The sky has been cloudy night after night. I'm going to go out there with my little telescope that my wife bought me so long ago. I'm going to see if I can find T Corona Borealis. Before we actually simulate the sky, how do you get started in astronomy? The least expensive way is binoculars, right? Which you can use, once you get bored, you can use it for other things like bird watching, spying on your neighbors. I don't recommend it. The prices have come way down for giant binoculars. Anything over 50 millimeters, the size of the lens, is considered pretty big. 60 on up, 80. And the prices are pretty low. I was astonished to see this because I spent a lot of money to see Halley's Comet in 63 millimeter binoculars many years ago. Beginner telescopes have come way down in price. Used to be you had to spend at least $200. Not anymore. The first scope that we sold here, might still have it, is about $79. Celestron. A couple big manufacturers are Celestron and Meade. Meade also owns Orion Telescopes, who have shuttered their San Francisco offices, which means I think they're filing bankruptcy, but they're still selling stuff online, so you might be able to get a discount. And if you like bigger telescopes to get more light, to see fainter stuff, like nebulas or nebulae. Nebulas, nebulae. There was a episode of The Simpsons where the crotchety owner of the energy plant was looking for catsup or ketchup. Nebulas, nebulae, it's the same thing. To see faint things, you need more light. 8 and 10-inch telescopes are more expensive, but these are the best, most economical, simple design, named after Dobson, invented the Dobsonian design. Canadioptrics are very expensive. They use a lens and a mirror, and I've got a small Maksutov. That's the one my wife got me. It has a mirror in back, lens in front, and a second mirror painted onto the lens, so the light comes in this way, bounces off the back, goes back up to the second mirror, bounces again through a hole in the first one. It's doing this. So the path, the optical path, is actually long. You get better magnification. Spy satellites use very long folded light path so they can actually see people from orbit. It's incredible. So as a reference, before you go home, and before we simulate the sky that you would see, UACNJ, repeat after me, UACNIJ. I didn't hear everybody. UACNIJ. Thank you. That's an umbrella organization of different observatories, planetaria, telescope makers. Sky and Telescope Astronomy still in print. I think we might have some issues. They have websites with subscriptions. Their websites also have huge parts that are free. Really great. You can get star charts, all kinds of information. Easiest to remember if you forget everything else. Don't forget what? The meteor shower, the Perseus, thank you. Great, she didn't have to say it. Space.com, how easy is that, right? Space.com, search for life, science, and news. And then apps, you can hold your phone up, your tablet. It will actually zoom in, you'll actually hone in with GPS as to what you're looking at, even through clouds. Pretty cool. I've used Stellarium, which is what I use to make the screenshots. It's all free. Everything's free. Some of them are good for photography. Some are good for just fooling around. And here's what Stellarium looks like from the website, which runs off their supercomputers. So if you don't want to install stuff from stellarium.org, you can just use their stuff, or you can get the free mobile version. Free Celestia, this is really cool, lets you fly through space to see what Saturn looks like from its moons, or what an eclipse of the sun looks like from the moon when the Earth hides the sun and the entire atmosphere is lit up red. It's like a ring. It's amazing. So let's take a look and see what's up. Stellarium is free. It's in version 24. Until recently, it was in version 0.17. How does that work? I don't know. I don't know how programmers think of these things. It's amazing. So where's the stars? This is the sky right now. It's summer, right? Not going to see stars. You have to stay up late. So in Stellarium, you can cheat and you can change the time and the date. We're looking at August 3rd, 1957. What's 19 minus 12? This is military time. No mathematicians in the audience? 19 minus 12 is 7. 7 o'clock. 7:52. 8:52. 9:52. We're getting close to 10 o'clock. Now we see a nice sky like this. And I'll tell you, if you're here when it's not hazy, this is an amazing observing site. I have seen not only the Milky Way, but I managed to see a nebula with the naked eye. And I was wondering, what is that little cloud in the Milky Way? It's a stellar birthplace. You can see it with no aid whatsoever. So to see that, I'm going to show it to you, but I want to start in north to get oriented. On a star map, like the kind we sell, shameless plug, a planisphere, there's a circular star chart in our gift shop, looks like that. But the advantage of a computer program is that you can zoom in and see the full size of the Big Dipper. What on earth is that? Cosmos. Oh, I froze the sky. I want to see the sky right now, and then I want to go forward. And now Cosmos is gone. But you won't see 7 stars in the Big Dipper. You will see, and you won't see lines either. So I'm cheating. You will see 8 stars if you look carefully in the Big Dipper. 1, 2 pointer stars, Merrick and Doobie. 3, 4, 5, 6, 7, 8 in the bend of the handle. So it's a double star and a parent double star. They're not revolving around each other. One of them is in front of the others. This one's 78 light years away. This one's 82 light years away. So it's an accidental alignment. There are real double stars in the sky. Like Mizar is called the spectroscopic binary because you can't split it with a telescope. You need a spectroscope. And these revolve around each other. So it's actually 3 stars or more that we're looking at there. So I'm cheating. I'm using lines that you'll see in a star chart. Not going to have that when you go outside. but this is going to make it a little bit easier for you. The head, the claws, the tail. Ursa major. What's Ursa? Bear. Yep. And so if there's a great bear, you can follow the pointers 5 times their angle apart, 5 degrees. Hold your fist out at arm's length. This seems to work no matter what your size is. I've heard 5 degrees, your fist roughly. Go 5 times, 5 fists, 1, 2, 3, 4, 5, and you'll pass right by the North Star, Polaris. In Ursa Minor, the small bear or small dipper. So you just found north, you found out where north is. It's actually about where my arrow is. The North Star is close to it. That's why we call it the North Star. But in about 8,000 years or so, it's going to be this bright star, Vega, in Lyre, L-Y-R-E, the harp. So the Earth is wobbling like a top. It's doing this. So there's a 25,000 year period. If you're like Mr. Spock, you want to know the exact figure, look it up in Wikipedia. It's 24,772 years. There's a clock in Switzerland that has that gear. It's precession. It's very slow. Can you feel it? No. But it does change all the astrological signs, and it changes where the Earth's North Pole points. Back when the Egyptian pyramids were built, Thuban, Alpha Draconis, was our pole star. Draconis. What's Draco? You ever hear this name before? Draco. In Stellarium, you can cheat a little bit. Dragon. Draco. Longest constellation in the sky. Formerly, that was Scorpius, which had its claws cut off to make Libra the scales. So if you can find these stars, the Big Dipper, Little Dipper, Draco, the House, Cepheus the king, the W, Cassiopeia the queen, these stars circle the pole always. They don't rise or set. They just go in a circle. They're up there 24 hours a day. Why don't we see them in the daytime? Yeah, it's too bright, the sun. The nearest star is in the way. So, now that we're oriented, we just look to the west. We turn from north at Jenny Jump that way is west. And we see the stars of spring disappearing. Arc along the Big Dipper's handle to Arcturus. Arc to Arcturus, 4th brightest star in the night sky. Orange color. Is it orange here? No, because Stellarium is not as good as the human eye at showing the colors. Very pretty bright orange star. Go up above it more southerly to the south, and you'll see Corona Borealis, the crown, northern crown, with T somewhere in here, very faint. I can't even see it. Yeah, in fact, I limited the brightness here so we don't see too many stars. That's not it. But it's going to show up right about epsilon, right about there. And it'll be almost as bright as these stars. Very similar. Corona. Corona is right next to, if you're looking very high in the sky, this is actually a really great place to look because you're looking through 5 miles of the densest part of Earth's atmosphere, the troposphere. If you're looking toward the horizon, hundreds of miles. So if you're looking through less atmosphere, it's clearer, right? You get a nice clear sky. You have a chance to see a deep sky object, deep sky, thousands of light years away. Look at the center of Hercules, called the keystone, shaped like the center stone in an arch, and look about 1/3 of the way down from the star in the top right, or 2/3 of the way up from the bottom star, and you'll see what looks like a fuzzy cloud, a little globe of stars. In binoculars, you can't see stars, more like a cloud. Small telescope, you see hundreds of stars. Large telescopes, thousands. There are 500,000 stars. This is a picture from the Hubble Space Telescope. This is the best seen globular cluster in the northern hemisphere. There's a bigger one, Omega Centauri in the Centaur. is very low in the south. So if you've been to Florida, you can see it there. This is M13. M13, Charles Messier's 13th object that annoyed him when he was looking for comets. Because comets are fuzzy, right? So he made a list of all the things that he wanted to forget. Why do we remember him 150 years later? All the stuff that he threw out. It's like my mother always said, don't throw anything away. M13, very cool. You can see it as a fuzzy blob, even in small telescopes. In Hercules. So is it really in Hercules? Well, let's see. This star is 35 light years away. M13's on the order of 10,000 light years away. There's thousands of these globular clusters going around the Milky Way, not in the plane of the Milky Way, but at all different angles. They're very old. They were born along with the Milky Way about 10 billion years ago. So they're pretty old. So we saw stuff that's pretty high. I want to look low in the sky down south. Then I want to look to the east to see the stuff that is coming up later on in the summer. If I look further down in the sky, I can see a couple of famous signs of the zodiac that are visible fully only this time of year. Don't miss them. Look, you need a nice clear horizon. I know that's tough. Where I live, I've got houses. They're replacing all the small homes with monstrous homes that eat up the backyard. Big, giant homes. Higher makes it harder to see the horizon. But if you can, look for Scorpius. Scorpius, the what? Scorpion. Very shy audience. And the teapot-shaped group of stars that we amateur astronomers call the teapot. Right? You see the spout, lid, handle. See the steam coming up? Milky Way. The center of the Milky Way and the supermassive black hole there, right above the spout. A little fuzzy cloud called the nebula, which if you look it up means cloud, nebula, star formation region, the lagoon nebula. Hydrogen gas glowing red of its own light. Lagoon of dust running down the middle. Looks like a lagoon maybe. Nearby the Trifid nebula, split into three parts. In a small telescope looks like 3 lobes. Hydrogen gas, what's this blue? There are very hot young stars that glow blue, just like the hot blue flame in a gas flame. Cooler stuff is higher, the yellow. Blue stars, young stars are born. They die quickly in just a few 100 million years. It's nothing. The sun is 5,000 million years old, 5 billion. Blue starlight reflects off of dust. Red hydrogen gas glows on its own. Dark dust doesn't glow at all. All of this stuff, the dust that looks blue, the dark dust is going to collapse someday to form stars and planets. How do we know? Because we see it happening. For the first time, the last 50 years, we can watch it happening. Not just theory. These are nebulae, nebulas, nebulae. Take your pick. And you can see this one with the naked eye here at Uwaknij. Amazing. It's dark enough to see the Milky Way from horizon to horizon. To actually see it on my projection, which is a little faint, I'm going to cheat a bit and I'm going to change the brightness of the Milky Way. Let's, instead of 1.2 times, let's really boost it up like 3 or 4. And that's kind of how it would look without the color here. Going all the way across the sky through Cygnus, the swan. Past Vulpecula and Sagitta, we saw those at the beginning, the fox, the arrowhead. Cygnus, the swan, I'm sorry, this is the eagle, Aquila, and the harp. And these have 3 bright stars in them. Bright star. Vega, which will be our pole star in the distant future. In the cross-shaped swan, Deneb, the tail. And down below, another bright star, Altair in the eagle aquila. And together, these three stars make a triangle. You can't mistake it, even if your sky is, as we say in astronomical terms, crappy. You can see the summer triangle. It's very easy. It looks straight up tonight if it's clear. Not tonight, tomorrow night, right? Not tonight. So the three constellations, eagle, harp, swan. Beautiful. In the center is a group of stars that's not a constellation, just like the Big Dipper. The Big Dipper is not a constellation. It's a piece of it. This is a group of stars that you'd find like an object you'd find in your closet, just upside down. Coat hanger, very good. It's famous asterism. If you're here at Jenny Jump next time, we have talks every clear Saturday night, every rainy Saturday night. Ask the amateur astronomers outside with their telescopes to show you the coat hanger. Whatever you do, don't kick the tripod. You'll make an astronomer cry. That's summertime objects. And if you look over towards the letter E, go outside, look that way for the letter E, right? No, you can turn the cardinal points on and off in stellarium. Look for this gigantic square rising. It's going to help us find the most distant object in the universe that you can see with the naked eye. I'll talk about that next time. And this big, giant, great square in the sky is part of the horse, the flying horse of legend, Pegasus. Perseus, Andromeda, Pegasus, Cassiopeia, all part of the story of Perseus and Andromeda, been up there in the sky for thousands of years. This giant, great square in the sky goes by the very hard to remember name, Great Square. And it helps you find the Andromeda Galaxy. We're going to talk about that in more detail next time. We're going to be looking for something that does not twinkle like the other stars, rising low in the east at 10:34 at night, is not a star but a planet. And look how much we have to zoom in to get any magnification at all. As it would appear in a small telescope, the planet with the rings. Saturn, thank you. And its brightest moon, the reddish moon Titan, covered with a reddish atmosphere. You can see that in even small telescopes. But Saturn has many moons. 6 bright ones you can see in small telescopes. I talk about that in a talk about the moons you can actually see. I've given that talk before. I'll do it again here. Out of Saturn's currently 146 moons, it holds the record. Jupiter, only 95. In larger telescopes, the rings of Saturn look like they're starting to close up. They will disappear entirely in a few months because they're just so thin. Saturn has many moons, beautiful object in a telescope. Currently in amongst the stars of Aquarius, the water carrier. And it'll be even a little bit higher next month when I give my talk, What's Up in the September Sky. Very good. Before I conclude with a review, any questions about anything that's up that I missed? Your favorite sign? Your favorite star? Yes. Would you like to, hold on a second. Here you go, laser pointer. Where about, or when and where? Throughout the year. Uh, and they make a diamond? Oh, in the winter sky, Orion, the hunter. Yeah, that, okay. So you would, I'm gonna have to take that back from me. I'm sorry. Yeah, that's I talk about Orion in the winter, and if you were to get up early enough, well, let's see. What if we just stay up late? Yeah, Orion is rising after 5 in the morning. At 4:30, there he is. Three bright stars in the belt, orange star Betelgeuse, and bright Rigel is bluish, Betelgeuse is orange. So your eye can actually see star temperatures. Yeah, I talk about this in detail in the winter. But again, if you were to get up early in the morning, you would see it then. What I'm going to do is conclude, because I want to leave time. I think we're running out of time for questions. And so all of this was simulated for you in a free program, Stellarium. Here's the review. So again, if you want to ignore the morning objects, uh, Jupiter is near Mars in the middle of the month. The moon passes both of them later on in the month. Don't miss Venus near Mercury early in the month. The supermoon, wow, supermoon in late in the month, the 19th. And if you forget everything else, the Perseid meteor shower, 12th. You don't have to stay up late. Best time is late. You can find me here, astronomyinmotion.com, where you can play with 3D objects with your fingers, any pointing device. You can move the globes around in a circle. You can zoom in for detail. You can hear my wife narrate videos in Mars at your fingertips. There is a paying version that's 4K. The HD version is spectacular and free. Check it out. You get to hear all about Mars' principal features, and all the landing and crash sites are there of all the stuff that ever went to Mars, including the 6 that died from the Mars curse. The Mars curse. Find all about it. You've been a great audience. This is where you find us, UACNJ, everywhere. And with that, I'm going to say thanks for being a great audience. I'm turning things over to Kim. Thank you.
All right. Thank you, Lonnie, for another great talk. Thank you, everyone who's joined us not only here, but also online. So, since there are a few people I think snuck in a little bit after I did the safety briefing first, we got to do that. If you need to use the restroom, that is the porta potty outside. It is illuminated by red. Wow, the lights, as if it wasn't bad enough looking straight into the projector. When we go to leave, we are using our headlights. We do not want to see anyone run over. Normally on a nice night, we would go stargazing after, and each of the sheds you saw when coming in has a roll-off roof and contains a telescope. With it being so rainy, we have not opened any of them up because we like it protecting our thousands of dollars worth of astronomy equipment. And normally we would ask if you have any flashlights or whatnot, do keep them pointed towards the ground so we don't accidentally blind people or we're not out there having flashlight raves. You laugh, but it's happened. Where someone had it go and I'm like, that's a skill, but let's not do that. So how question and answer is going to work, you guys have it easy. I can actually see you indoors with the lights, so you can just raise your hand. You don't have to wave it about this time, because in the light, my vision's not just movement based. Online, you have it even easier. Just type it in chat. So we'll start off with the first online question. How long will it take until the rings of Saturn are fully open again?
Oh, Saturn orbits the sun every 29 years approximately. Divide by 2 is when it hits the same plane as Earth. So it's doing this in a cycle. So 14 years, again, from now, they'll be fully open. So 14 plus 2024, 2038.
Cool. Question out here?
Oh yeah, don't be shy. Just shout out your
And
question.
it doesn't have to be necessarily about the presentation. We've had some general astronomy questions as well.
Sure, I'll even tell you my favorite color.
Let's see. Our next question. Do we have a better idea of when the T Corona Borealis thing is going to be actually apparent? It feels like we've been waiting for it since April.
The answer is none whatsoever. This is unpredictable. I mean, it's overdue. That material is going to blast off the star and hit that disk going around the dwarf star. That's an accretion disk because it's accreting, collecting. And we know it happens every 80 years. just not yet. So be patient.
Follow-up question, because now I'm curious. What happens if it doesn't do the thing?
Astronomers will cry.
Questions? Just whenever you have a question, raise your hand.
Sure. I want to thank a couple of members of the audience for being out there and really taking a risk and putting those answers out there. Thanks.
So online chat had gotten off on a tangent, and I did put it in online chat. But UACNJ does not condone acts of pyromania and suggests you don't try making fire tornadoes at home, especially in areas that are currently dry and crunchy right now. Yeah, they got off on a tangent where it's like, how you been doing with the heat? And it's like, I'm not a fan. And there's the problem, you don't have a fan. Well, we also have tornadoes, and someone suggested getting multiple fans and making a fire tornado. And let's just not do that. Everything's, even after the rain, everything's very dry and crunchy. No. We are in a state park, so definitely would like to keep the state forest as a state forest, not a state barren mountain. So our next online question is, what will be the next pole star after the one in Lyra?
Oh, why don't we figure it out? We can simulate that. I like that. We can see, what we can do is look at the whole precession circle and just pick a star, any star. The people in the southern hemisphere are at a disadvantage. They've got a faint star, Sigma Octans, in the octant, or Sigma Octantis. I'm going to face north to do this. So they don't have a bright star right now, but we're going to be in the same position in another few hundred years. So what I'm going to do is I'm going to turn on markings, and you can do this at home, kids. This up. I'm looking for the precession circle and the position of the pole. Celestial pole of date. Celestial poles 2002. We don't need that. There. We could go forward in time very quickly to see, but there. Now you see where the pole star is going to be. Vega is kind of off. So is Deneb, and the Polaris seems to be the brightest star in that 25,000-year cycle. There's one. Alpha Cephei, Alpha in Cepheus. The next pole star is going to be, next bright one would be in Ursa Minor. Ursa Minor, the Little Dipper. Well, we're in the Little Dipper now, and it's called 2. Wow, what a great name, 2. 2 Umi, Ursa Minor. Astronomers have 3-letter abbreviations for each of the 88 constellations. So
this is our current one.
What's our next pole star? Well, it's going to drift. I would say that one. HIP 115746. Everybody memorize. HIP 115746. Wow, that's really sexy. Well, the next one of any note will be in Cepheus. Gamma Cephei. Why don't we see when this is going to happen? You ready? Let's go forward in time.
Whoa.
I didn't go forward.
The flashlight raves kind of look like that.
Yeah, it's good. You know what? I will figure this out at home, and I'll let you know next time, because it's going to take a lot of zooming forward. But
I feel like you should be able to type in about 8,000 years from now.
Yeah, it's not going to be 2025. Why don't we say 99999999909? Where's our pole star? Wow, things are really different, aren't they? North Celestial Pole is over here. Oh, we went too far. Look, the constellations are distorting. All right, tell you what. Why don't we just pick 5000 AD?
You know it's bad when your constellations have decided.
All right, in the year 5000, it's, oh yeah, look at that. It's in Cepheus. How about we go back to 4000? You see how it does take a lot of, yeah, there you go. It'll be Gamma Cephei in around 4000. Can't wait. I'm waiting for, wait, what about Vega? Now, I once saw a book that said 10,000 AD. Where's Vega? Oh, it's set. Well, let's see. All right, let's see if they're right. I think it's either 8,000 or 10,000. 8,000, the North Celestial Pole. Still in Cepheus. Nope. Liars. 10,000 AD. You know, no, there's no. Wow, they led me astray. Well, what
Some
do you,
research in math is
who
going
wants
to
to
need to
guess?
happen.
What should I put in here? 20?
This is why the math is important.
No, looks like it's going back. Oh, wow, we bypassed it. Let's go back to 12,000. Oh, yeah, they said in 10,000 years. That's pretty close. 12,000 time. Uh-oh, I lost my time.
While he's looking, were there any more questions out here? Also, online chat, do get your last minute questions in.
Nah,
What's your favorite constellation and why?
my favorite constellation. I'll tell you the one that isn't. Well, let's see. My zodiac sign is supposed to be Capricornus, the sea goat, half fish. Looks like a bikini top or a bikini bottom, depending on which stars you draw. And I was actually born when the sun was in Sagittarius, because astrology is off by an entire sign, since the Earth has wobbled since it got started. But my favorite constellation, I like Orion because it's got some bright stars in it. I really haven't thought much about that. I'll do some research. I'll have to think about that. Favorite constellation. Probably, I don't know. You stumped me. Wow.
What's your least favorite one? It seemed like you had one in mind.
Well, I'm not thrilled with Vulpecula. I mean, it's 2 stars. That's a fox? Really? Oh, there's another one. 3 stars for Aries the ram, sign of the zodiac. Just 3 stars. How did they get a ram out of that? People, the ancients, they did have a very clear sky. They had more stars. They also had drugs.
Yeah, I have a feeling that's one of they had more stars going on, and
Clear skies, no light pollution.
yeah, oddly enough, if you're here, you're like, wow, I can't find the Big Dipper if you're used to New York City skies. But if you're used to these skies and you go out to like the desert in Arizona or somewhere in Montana, you're like, oh no, there's too many.
Oh yeah, yeah. I was in Vermont once looking for Cepheus. I could see the W, so I know that her husband's up there right near. I could not identify it. There were so many stars, and they are brighter than the others, but you can make up your own patterns.
Actually, the reason why Ursa Major is my favorite is because in Montana you can actually see, because there's so many stars, you can actually see legs, and you can kind of see like a big head, and it looks bearish.
Yeah, she just shared a story where she grew up in Montana. The constellation Ursa Major looks much more like a bear because it has the extra stars filling it in.
There's an author, H.A. Ray, R-A-Y, who wrote a book, not really for kids, it's for everybody. He redrew the constellations so they would look more like what they're supposed to be. So check that out sometime. That reminded me.
Right. So an online question we got, and I don't know that you're going to be able to answer this one, but where is the best spot in New York State to see the Milky Way?
In New York State, there are some state parks, aren't there?
Oh, there's state parks everywhere.
Mm-hmm.
Your best bet is look at a dark sky map. We only have one for New Jersey for our surrounding clubs. I haven't offhand really looked at New York too much. But if you look at a dark sky map, it'll give you the gradient of here's where all the light pollution is, to black. I don't know. There's a color gradient there. and look for where it's towards the dark end of the scale, and that's going to be your best spots.
Stay away from Albany.
Yeah, oddly enough, major cities not that great for watching the Milky Way because of the light pollution. Yeah, a couple people are suggesting Catskills or Adirondacks for good starts. Um, any other questions out here?
The distance to
Can you say that again?
What's like the distance limit for the stars that we can see from the Earth?
oh, distance limit. That's a very interesting question. When you're looking in the sky, the stars are at all different distances, and each one you look at, depending on how far away it is, you're looking further and further back in time. So, for instance, Sirius, the brightest, the dog star in the winter, that's only 8 light years away. So you're seeing it as it looked 8 years ago. But some of the stars of Orion are 1,500 light years away. And yet stars live so long that to them, that's nothing. So the answer is it's all different distances in time. So you can see, depending on how bright they are, the brighter stars that are further away, like in the summer triangle, the nearest one is 16 light years away. That's Altair in the Eagle, but the tail of the Swan, Deneb, is about 1,000 light years. You can still see them both. If you brought Deneb toward to where the sun is, it would melt the inner solar system, burn it up.
So I think that also depends on, are you talking naked eye or are you talking aided with a telescope? Because with a
Oh,
telescope you're looking at and I'm fairly certain they did an article on it. Look up what the James Webb Space Telescope, where they put their, here's where we could see to, because that'll give you the furthest object we have found out so far, within a margin of error. Because when you're dealing with large distances, you you know, it's not like Earth where you're like, oh, it's a couple blocks over and it could be a block one way or the other. But at that distance, it's like, oh, yeah, that's within a couple thousand miles. That's good enough.
yeah, with the James Webb, they're looking back just almost to the edge of the observable universe, and that's 46 billion light years. It's a big universe, and yet what we can see is only a tiny fraction of the whole real universe. We're not going to ever see it all because the light takes too long to get to us.
All right. Looks like that took care of the online questions. Any last minute questions here? Oh, we got one.
So when there's two stars orbiting each other, do they have planets? Because they would mess up each other's planets, right?
That I don't know if everybody heard that. Yeah, a double star or multiple star systems might have planets, and it used to be thought from calculations like the three-body problem that creates chaos, and the planets would not be able to hold on, or the stars cannot hold on to their planets. But now we have massive supercomputer simulations that show that that's not true, no longer true. There are stable configurations where especially a double star system acts like the attraction of a single star. So there can be stable planetary orbits around those. It will be most interesting to find if there are Earth-like planets around the nearest solar-like stars to us, the double star Alpha Centauri. It's a triple star system, but there are two sun-like stars close to each other relatively, and Proxima is a red dwarf that goes around them at a much greater distance. Proxima is nearest to us right now, but the other two are only a fraction of a light year further away. We got to find out if there are Earth-like planets there. There very well could be. So the answer is, yeah, there could be stable configurations around multiple star systems.
Possible, not discovered yet.
Right.
All right. Any last minute? All right. So thank you all who have joined us here. Also online, a big shout out. Thank you, Lonnie, for a great presentation.
Thank you very much. Great audience. Thank
And
you for your help.
With that, have a great night, clear skies, and good seeing.
Hope to see you again.